So this chapter we're going to learn a bunch of different ways to solve linear systems. The first way we're going to do it today is to solve by graphing. Right here we don't, like I said, go over definitions all the time, but it's important to know what we're dealing with. A system of linear equations is a set of two or more linear equations in the same variables. An example is shown below. So we have x plus y equals 7, 2x minus 3y equals negative 11. And it says it's an equation in the same variables, meaning x and y. A solution of a system of linear equations in two variables is an ordered pair. So whenever we get our answer, it's going to be the coordinate point x comma y where the two lines meet. So to start off with, our first example here is going to be going over how to plug in some points and see if it's a solution or not. Before we do that, I wanted to put this core concept box in your video. So I would pause this and make sure you have this core concept box copied down so that you know how to do it step by step. So as part of example 1, we'll go ahead and do it in example 2 here in just a second. What we're going to do is actually go ahead and graph these lines. So what I'm going to do is I'm going to graph the top line in blue, and I'm going to graph the bottom line in red so that we can see which lines are which. Hopefully we still recall how to graph lines in slope-intercept form. So we look at the y-intercept, it's 5. So I go up 5 and plot a point on the coordinate plane. Then what I do is I use my slope to plot several points. So I go down 2 and right 1, I plot a point. I go down 2 and right 1, I plot another point, and I'm going to plot a couple in both directions. Instead of going down 2 and right 1, I could also go up 2 and left 1 because that falls on the same line. So as you can see, I've plotted several points on my line. Sorry, it's not perfectly straight, but you get the point. The red line's y-intercept is negative 1, and what I'm going to do is plot several points. If I have to, if I don't have to, I'll be done. As you can see here with my slope of 4, I can go up 4 and right 1, and that is actually the first point is where I cross the other line. I could go down 4 and left 1, so you can see here where that point would be. But it looks like we've already found our solution to this system. The solution looks like it's going to be 1, 3. So the important part is we don't anytime want to just assume that that's right. What we can do to check our work on this problem is plug them into both equations and make sure that that's what we get for answers. So in the blue equation, if I plug in 1, 3, I get 3 equals negative 2 times 1 plus 5. 3 equals negative 2 plus 5, and I get 3 equals 3. In the red equation, if I plug in 1, 3, I get 3 equals 4 times 1 minus 1. 3 equals 4 minus 1, and as you can see there, we will also get 3 equals 3. So we can see that if we do plug in that point, that it is a solution of the system because it works for both. In example 1, what they do is that same thing that I just did right down here to check the work, but instead of getting it to be true every time, what's going to happen is every once in a while, one of the two statements is going to be false. Now, keep in mind that just because it's false, it's not true for one, but it is true for the other. That does not mean that those two lines don't cross. It just means that they don't cross at the point that you were given. So I always like to give you guys an opportunity to try and do these by yourself. So go ahead and try 3, 4, and 5. I'm going to work them out on this coordinate plane here to the right as soon as you guys pause and have an opportunity to try them. I'll do them one at a time. So what I'll do is I'll do one and then erase it, find the solution, and then I'll do another one, erase it, find, and make sure I found the solution for all 3. So number 3 here. Top line I'll do in blue again, bottom line I'll do in red. My intercept is negative 2, my slope is 1, so that top line looks like this going through the coordinate plane, and you can see Like I said, my lines aren't going to be perfect, but you can see that it kind of looks like that. The bottom line, I have a y-intercept of positive 4, so I go up 4 and I plot a point, then I go down 1 and right 1, and I continue to plot points. And it appears that my solution is 3, 1. So for number 3, I'm going to put 3, 1. Now, I'm not going to show the work here, but I will talk through checking to make sure that that's correct. So 1 equals 3 minus 2, that gives 1 minus 1, or excuse me, 3 minus 2, which is 1 equals 1, so it checks out for the first one. The second equation, 1 equals negative 3 plus 4. Negative 3 plus 4 is 1, so I get 1 equals 1 for that one as well. So 3, 1 checks out. That is my solution. Again, I'm going to go ahead and erase this. So there's what the picture would have looked like. Sorry, I didn't draw the line right away. But there's what the picture would have looked like for 3. Number 4, like I said, I'm going to erase and then start from scratch on that coordinate plane so that we can see all the work. So on number 4, top line, my y-intercept is 3. My slope is up 1 over 2. So I'm going to draw a few points with that slope after 3. I can also go down 1 and left 2 and stay on that same line. Okay, and I'll draw my line here real quick. The second line, I have negative 5 for my y-intercept, so I go down 5 and I plot a point. After I go down 5, then I use my slope, which is negative 3 over 2. Instead of going down 3 and right 2, what I'm going to do is go up 3 and left 2. Go up 3 and left 2, and it looks like right there is where they intersect. So once they intersect, I estimate what that point is. Again, it looks like they cross there, but I could have made a mistake, so I always want to check my work. But it looks like my solution is negative 4, 1. So I'll write that down, and then I'll kind of talk through what that would be. So 1 equals 1/2 times negative 4 is negative 2. Negative 2 plus 3 is 1. So 1 equals 1. That checks out for the first line. The second line, we have 1 equals negative 3 over 2 times 4. The 2 and the 4 would cancel out, and I would get 2 times 3, which would be negative 6 minus 5. But since that 4 is negative, it would be positive 6. So it would be 6 minus 5, and I would get 1 equals 1 again. So we found that negative 4, 1 checks out. So again, number 5, I will erase these things off the coordinate plane. It looks like it won't let me erase. Sorry, guys. So I'm just going to have to graph them on top. Before I can do number 5, what we have to do is put things in slope-intercept form. So 2x plus y equals 5 needs to be moved to slope-intercept form. All I have to do is subtract the 2x over, though, and then it's fine. I can graph it that way. The second equation, 3x minus 2y equals 4. I subtract the 3x, I get negative 2y equals negative 3x plus 4. I divide everything by negative 2. I get y equals 3 over 2x minus 2. Again, what I want to do is graph the first line here in blue. So positive 5 is my intercept. I know I have that other picture there, guys. I apologize. But I'm going to go up 5, and I'm going to plot a point right there. There's my new line. Let's actually do it in a separate color so I don't have this problem. Let's go, instead of blue, let's go with orange here. So I'm going to change this to orange. So positive 5 is my y-intercept. And then what I'm going to do is use my slope, down 2, right 1, down 2, right 1, down 2, right 1, and so on. Then I'm going to do the other line. Let's say instead of red, let's do it in green. So we'll do it in this color green. So I have negative 2 for my y-intercept. And then I have up. I go up 3. So I go up 1, 2, 3, and over 2. And it appears, it appears that my intersection is this point right there. It looks like my solution. It looks to be 2, 1. So if I plug those into my equations, I can even plug them in clear back up here at the top if I want. So I can plug in 2, 1 there. 2 times 2 is 4, plus 1 is 5. That one checks out. 3 times 2 is 6, minus 2 times 1 is 2, which is 4. So both of these you can see check out. You can also plug them into the slope-intercept equations if you want. You don't necessarily have to, but that will indeed tell us that our solution is correct. So you can see those two different problems there. Again, you guys, please make sure that you're trying these on your own, but the green and the orange are together, and then the blue and the red are together on that other one. Lastly here, you guys, we have some of these real-world examples. If you ever have a question setting them up, please just ask. But what we're doing here is basically assigning variables to different things. It says contractor buys 30 bundles of shingles and 4 rolls of roofing paper. So essentially what they're doing is they're assigning X to shingles and Y to roofing paper, and having you graph this function here, 30X plus 4Y is equal to 1040, and they're having you graph the intersection. Please understand that if you ever get a story problem on a test, it won't be like this. You won't be able to really graph this very effectively. So I will definitely help you guys have one on your test that is more attainable on a 10 by 10 square if you have one at all like this.